Okay, take down the next question. Calculate the amount of reinforcement required for singly reinforced T section for the following details. Singly reinforced T section for the following details. Working moment is 600 kilonewton meter. Working moment is 600 kilonewton meter. Consider M20 and Fe415. Consider M20 and Fe415. Okay, and the T beam I will draw. So take the dimensions from that. So the dimensions of the T beam are like this. The width of the flange is 1100. Okay, so the width of the flange is 1100. The depth of the flange is 100. And the width of the web is 300. And the effective depth is 800. Okay, so these dimensions are given to you, and the working moment is 600 kilonewton meter and M20 and Fe415. So what we have to find out? So we have to find AST. Okay. So now what you will do first? So basically it's a design problem. You have to find out the reinforcement. So first we will see that it is given in the question that this is your working moment. So what is the first step? First we will have to find out the factored moment. Okay. So working moment is given to us. So therefore factored moment is how much? Give me the value.
900.
900 kilonewton meter. Okay. So now the next step is calculation of XU. Okay. So to calculate XU, we will have to make an assumption. So what assumption we will make?
XU is greater than DF and DF is greater than 3 by 7 XU. So you are not audible.
Yes. Hello. Am I audible now?
Yes, sir.
So let us assume XU is greater than DF and DF is greater than 3 by 7 XU. So now since moment is already given to us, we will use MR is equal to CU1 into lever arm 1 plus CU2 into lever arm 2 to find out what? To find out XU. So what is CU1 into lever arm 1? 0.36 FCK B into XU into lever arm is D minus 0.42 XU plus 0.446 FCK BF minus BW into YF into D minus YF by 2. Okay, so MR is how much? So where first we will have to put the value of YF. YF is 0.15 XU plus 0.65 DF. So now give me the value of XU. Yes, give me the value of XU. 'Okay, anyone got the value of XU? Please write in the chat box.
238.69.
Okay, so XU is 238.69 mm. So we got the value of XU. Now we'll have to check this also. Correct, we have to check this condition. So what is the second condition? Find out 3 by 7 XU. So now 3 by 7 XU कितना आ रहा है?
102.29.
102.29. So this should be less than DF. DF is what? So therefore, actually DF should be greater than this. No? So DF is not greater than this. So this is not satisfied. So DF is not greater than 3 by 7 XU. So hence the assumption is incorrect. So now what we will do, we will have to change the assumption. So let us assume XU is greater than DF and DF is less than 3 by 7 XU. So now assume XU is greater than DF and DF is less than or equal to 3 by 7 XU. So now give me the value of XU. Okay, so the equation will remain the same. Only in place of YF it will be DF. Am I correct? So this will be now give me the value of XU. Yes, what is the value of XU? 241.8. Okay, so now we got the value of XU. ये check करो 3 by 7 XU कितना है? What is 3 by 7 XU? (103). So 103.63. So this should be greater than DF. So it is greater than DF. And X. So you can write, hence our assumption is correct. So hence our assumption is correct. So now one more thing you have to check is find out XU max. I think the grade is FE415. So this should be 0.48 D. So what is D?
384.
Okay, XU max is 384. So XU is less than XU max. So therefore XU is less than XU max. So hence it is an under reinforced section. Okay. So now all the assumptions are correct and it is an under info section. So now we can proceed and find out the AST. So to find AST, we will equate CU equal to TU. Okay. So let us equate CU equal to TU. So this is 0.36 FCK B into XU plus 0.446 . Okay. So now give me the value of AST. So which implies AST 3423. Rohit is saying 3423.04. Just check others. 3423. So we got the value of AST. So now we have to provide the steel. Okay, so what is the width of the beam? So now select a suitable diameter and give me the number of bars for this area. I think the width of the web is 300 mm. Okay, so give me the combination for this. Yes.
32 dia, 5 bars.
32 dia we will select. Okay, so how many bars it will become?
5 bars.
5 bars. Okay, so provide 5 bars of 32 dia.
And if we take 25, it's 7.
Okay, so AST provided it becomes how much in this case? 5 bars of 32 dia.
4021.
4021. This is, it's a huge difference, right?
बहुत बड़ा है.
So can you give some other combination apart from this? Yes, anyone? So you're using 32 bars, so 5 32, you're getting actually a lot of difference. So
So
combination
if
of
we take 25 dia, 7 bars are required, and AST provided will be 3436.11.
7 bars will be required, right? So 7 bars कैसे provide करेंगे? 336 we can provide.
Yes.
ठीक है, एक से ज़्यादा हो जाएगा. So tell me if we go for a combination of 32 and 25, then tell me how much. Suppose if I take 3 bars of 32 and 3 bars of 25, so कितना आ रहा है?
से कम आ रहा है 3300.
3 bars of 32 and 3 bars of 25. ये बताओ मुझे.
से
3 bars of 32.
3394. 3394.
Okay, so we cannot provide this if it is less. Yes, some other combination.
2 bars of 25 and 3
Sorry
bars
sir.
of 32.
Sir, 3 bars of 32 and 3 bars of 25 का आ रहा है 3885.
Okay, 3885 आ रहा है ना, so we can provide. So 3885. Okay, so let us go for this combination. Okay, so we have provided the steel in 2 layers. We can easily provide 3 bars bottom layer 32 and then the second layer 3 bars of 25. So now let us actually go for the check. So सबसे पहले we will check for XU. So to check for XU, let us consider XU greater than DF and DF less than or equal to 3 by 7 XU. So now give me the value of XU. Okay, give me the value of XU for this. CU1 plus CU2 equal to TU. If you do, you will get the value of XU. Just quickly.
319.07.
Okay, 319.07. So we got the value of XU. So now just check 3 by 7 XU. 3 by 7 XU is how much?
136.
So this is 136. So this is greater than DF. Okay. So this is greater than DF, and hence our assumption is correct. Okay. So at the meantime, we will also find out XU max was how much? XU max was 384. So therefore, all the assumptions so all the assumptions are correct, and it is an under reinforced section. Okay. So this check is done. So now second is MR. So check for MR now. Cu1 into lever arm plus Cu2 into lever arm. I hope you know the equation for this. So give me the value of MR. So then our check will be complete and the problem. Okay, so after this you will have to show the reinforcement detailing also. Okay, so show that reinforcement detailing.
So can you write the equation?
Equation for this, yes, what is Cu1? 0.36 FCKB into XU into
So
lever arm is
994.
okay, D minus 0.42 XU plus Cu2 क्या है 0.446 FCK BF minus BW into, this is the second condition. Okay, so into DF into Y minus DF by 2. This is the lever arm.
So MR is 994.2.
Okay, so this is 994.2, and what was this? Was the factored moment, that is mu. Okay, so this is greater than mu, so hence say. Is this clear? Okay, so we are done with the design problem. So far we have done how to find out the MR of a T section, of a singly reinforced T section, and we have also seen how to design to find out the reinforcement in a singly reinforced T section. In the next lecture, in the next session, we will start with the analysis of a doubly reinforced T section. So in LSM, you have singly reinforced and doubly reinforced rectangular sections, and you also have singly and doubly T sections. Okay, is this clear, everyone? So I think we have only 4 minutes left. So in the next session, we will start with doubly reinforced T sections and the problems for that. Okay, so in this, anyone has any doubt, they can ask me.